So let's say we have a ball and we throw that ball in the horizontal direction going 25 meters per second. And let's say that once the ball leaves our hand, it travels a horizontal distance of 50 meters before it hits the ground. We want to calculate at what height was the ball thrown. To do this, we just need two equations. We need to know that the velocity is equal to the change in position over the change in time. And we need to know the kinematic equation x final is equal to x initial plus v initial delta t plus, oh, that should be a plus, not an equals, plus 1/2 a delta t squared. So breaking this down, we have to first kind of ask ourselves a few questions. Do I have a velocity in the x direction? Yes, I have an initial velocity in the x direction, so I'll put another subscript there, of 25 meters per second. Do I have an acceleration in the x direction? And the answer is no, I don't. The acceleration in the x direction is 0, because once the ball leaves my hand, the only force acting on it is gravity, which is pulling it down, so all my acceleration is in the y direction. So that answers our next question, do I have acceleration in the y direction? And the answer is yes, it's gravity. So 9.8 meters per second squared. And then do I have a velocity, do I have initial velocity in the y direction? And by the nature of the problem, because the ball is only thrown horizontally, the answer is no. I do not have a velocity in the y direction. So let's first look at our velocity equaling the change in distance over the change in time. I'm really looking for the change in time. So I'm going to rearrange this equation. So delta t is equal to delta x over v. And what I'm going to do is I'm going to plug this in for all my delta t's in this equation. So I have x final equaling x initial plus v initial delta x over v plus 1/2 a delta x over v squared. The next thing I'm going to do is I'm going to further simplify this. We've got a lot of x's in this equation, and not all of these x's mean the same thing. The thing that we're looking for is actually our change in height, our change in y. This x is a general term for change in position. So we can kind of rearrange this. We can put different variables in it to kind of clear it up a bit. I'm going to actually just call these h. So this is our h final equals h initial plus v initial. And in this term, because I'm looking for the height, this initial velocity is the direction, is the velocity in my y direction. So I'm going to put a subscript there to reference that it's vy. I'm going to keep this x as delta x because it is our change in x actually in the horizontal direction. We've calculated that from this original equation over our velocity plus 1/2 acceleration times delta x over v squared. So now this is looking a little cleaner. We can even simplify it further. Because we're just looking at the overall height, we can actually simplify this to be delta h, because we can set either our initial or final to 0, because we're just looking at the overall difference. And then I can set that equal to, if we remember back, we set our initial velocity, we said it was 0 because the ball is only thrown horizontally. So the velocity vertically starts off at 0. So this whole term goes to 0. I'm looking at 1/2 acceleration, which is my gravity, right? So this is my gravity. We'll put a subscript there because it's the acceleration in the y direction. And then delta x over v squared. Now I have my final algebraic equation, and I can plug in all my variables to solve for this. So delta h equals 1/2 times 9.8 meters per second squared, multiplied by 50 meters divided by 25 meters per second, and that all is squared. And if I plug it in my calculator, find my change in height is 19.6 meters. So the ball was thrown at a height of 19.6 meters.